All right, so I have a question here. It's looking for theoretical yield of chromium. I also need to answer what is the limiting reagent. So I have starting amounts of the chromium oxide and aluminum both. And my general technique here is going to be to figure out how much chromium I can make from each of those. So first I'm figuring out the molar mass of the Cr2O3. So I'm looking up the molar mass of chromium, multiplying that by 2. And then the molar mass of oxygen, 3 of those. And I get 152 for my molar mass of the chromium oxide. I started with 40 grams of it. I'm going to put the molar mass on the bottom to divide so that the grams cancel, and I'll be in moles of the chromium oxide. Now, what I want to know is how much chromium I can make, so I'm going to go from moles of chromium oxide to moles of chromium. And I'm using stoichiometric coefficients. So for every 1 Cr2O3, I can make 2 chromiums. And then I'll see how many grams that is using the molar mass of chromium, which is 52 grams. So this is if I use up all the chromium oxide, how much chromium will I make? And I get about 27.4 grams. Now I'm going to do the same thing. What if I used up all the aluminum? I started with only 8 grams of that, but what if I used all of that? So 8 grams of aluminum, molar mass of aluminum, so that's the 27, and that'll get me to moles of aluminum. Now I'm going to use the stoichiometric coefficients to go from moles of aluminum to moles of chromium. I want to go to the same product as I did the first time. So 2 moles of aluminum will make 2 moles of chromium, and then the molar mass of chromium. So let me put that in my calculator. And I get 15.4. So once I have these 2 masses of chromium, whichever one is smaller is the theoretical yield. That's how much I can make, because I'm going to run out of aluminum before I ever get past 15.4 grams of chromium. And so the thing I would run out of is the aluminum, the one that got me the smaller answer.